electronic transmission install simple? This is what we're going to talk about today. So what we're here to cover is to get you guys the background and the knowledge that you need to understand the different types of transmissions that are available and how to pick the best transmission for your package and for your installation to make your project successful. Quick overview of who PCS is, or are. We're an engineering and production firm. Our specialization is automotive driveline. We do 100% of the design and development is done in-house along with the manufacturing. We manufacture 100% of our products in-house. There's no outsourcing during any step of our development. We do everything at our production facility. Our specialization is transmissions. So we know when it comes to transmissions, we know everything there is to know about them, hydraulically and electronically. We have 2 locations. We have our engineering and corporate headquarters located in Ashland, Virginia. If you're not familiar with that side of the country, we're just south of DC. Our production facility is in Sharon, Pennsylvania, which is north of Pittsburgh, just outside of Youngstown, Ohio. Once again, all of our products are made here in the U.S. We have 3 sales offices. Obviously, we have a sales office at our location in Ashland. We also have one here in the Detroit area, and we also have one in Shanghai. The Shanghai office is solely for our OE level sales, but the Detroit office specializes in the aftermarket and performance racing, and our Ashland facility does everything. Okay, so what are the advantages of electronic transmissions? The biggest one, obviously, is the ability to calibrate the transmission for a wide variety of engines and vehicles. That means if you have different power levels, different weights, different axle ratios, tire sizes, things of those natures, you can, with the electronics, you can make your adjustments to calibrate the transmission directly to the requirements of the vehicle. Which means you don't have to get inside the transmission to adjust modulators or accumulators or anything like that, mess with spacer plates and orifices and things to get the shifting the way you need it for your particular vehicle. It allows you to take one transmission that can work in a very lightweight, high-power vehicle and also use it in a heavy, low-power vehicle. Also, electronic transmissions are almost always overdrive. So overdrive transmissions are obviously in everything that you drive today. Allow you to reduce your cruising RPM, increase your fuel economy, and just make it generally a more pleasable vehicle to drive. The other advantages of electronic transmissions are diagnostics. So transmissions today and the control modules are able to detect problems in the transmission and take steps to protect the transmission from any further damage that may have happened. So what that means is if something goes out in the transmission while you're driving, generally you're going to get some kind of limp mode to get you home. It's also going to let you know something is wrong because all of a sudden either your check trans light comes on if you have one, or the trans is just stuck in one gear. So that gives you an indicator that there's something wrong. Also, electronic transmissions are what comes behind all of your new engines. So if you're using any of your newer engine options, electronic transmissions are pretty much your only option that you have, besides manuals, obviously. The other advantage of electronic transmissions is you can get the best of both worlds out of one. You can have a firm shifting, performance style shift at heavy throttle, and hey, I like to drive this thing around town and don't want to get my teeth knocked out at light throttle. Okay, all electronic transmissions are not created equal. What this means is that unlike engine control, which is very standardized from one manufacturer to another, electronic transmissions are not. So a Ford transmission does not use the same control system as a Chrysler transmission, which is not the same as a GM transmission. So what may appear on the surface like they are similar because you tell it what gear to go into and that's the gear it goes into, What happens in the hydraulics and the electronics is very manufacturer dependent. And so what that requires us to do is our control modules have to be flexible and universal so that they can be configured for whatever type of transmission that you want to do. So understanding these will give you a big advantage in choosing which transmission that you want to use, because some of the transmissions are hydraulically are simple, which means electronically they are complex, which means that they will take more effort and more work to calibrate. PCS internally, we divide this into two generations of transmissions. So our first generation transmissions and our second generation transmissions. First generation being the simpler designs, easier to work with. The second generations being the more complex ones. Your typical first generation transmissions would be something you'd find from your mid-90s through the early 2000s. Most of the complexity of the shifting is still handled hydraulically. So the electronics have a very limited amount of things that they can do, and it's still mostly a hydraulic transmission. So they're electronically simple. So you'll typically have on-off solenoids and a single pressure control. They're simple to tune. I'm sorry? Yeah, so some of the solenoids are pulse width modulated, some of them are on-off. Your typical pressure controls, anything that's doing a pressure control where it's a linear amount of pressure based on the current going through the solenoid, those are pulse width modulated. And your first generation transmissions will typically only have one, sometimes two of these style solenoids. The rest of the solenoids would be on-off solenoids or simple controls. These transmissions are relatively simple to tune, meaning that there's not a lot of parameters to adjust. They're easy to understand what's going on, and they're also more difficult to damage when you get some numbers wrong. We also recommend these for everybody. It doesn't really matter what your skill level is. Your skill level and your understanding is only going to dictate which controller you pick. It's not going to dictate whether you use an electronic transmission or not. What we're saying is that we can sell these transmissions to anybody, but depending on the type of control that you want to do with it, we would sell you a different module to go along with it. Some of the modules are simple, really easy to use, and some of them are more difficult. Well, what it is, we build several TCMs that will work with a 4L60E. And so, yeah, and we'll get to those later in the presentation. And what we're saying is that depending on what your skill level is in electronics, we're going to either sell you one that gives you a very limited amount of adjustments, or we're going to give you one that gives you full control. You can do anything and everything you want, or we're going to stick you in this little window and be like, okay, you can move your shift points, you can move your converter lockup, and you can move your shift firmness, but you're constrained within limitations so that you don't confuse yourself, and so you make the installation much simpler. So if you're not doing anything crazy, then we're going to put you in this simple module. Or if your skill level is relatively low, you're not handy with a laptop, or you're in a hurry, you don't want to spend weeks calibrating this thing. You want to spend 5 minutes calibrating it. We'll give you this module. But if you like the ability to go in and do whatever you want, we're going to sell you something different. And so we'll get to that later on about which module would be best for your skill level. Yep. And back to your analogy about the Turbo 400 versus the 4L60E, it's still a similar system. You've got your governor telling it when to shift. That's electronic. Basically you have an electronic governor and you have an electronic modulator now. And so because there are other conditions you can compensate for, and so you can make the transmission shifting better than the original mechanical systems were. It also gives you a wider range of adjustment. So you can have firmer shifts, softer shifts, all in the same package. This is a typical list of what we consider our first generation 4-speeds. Okay, so you have your 4L60, which is what we were talking about. Yes. Mm-hmm. Yeah, that would be a non-electronic. So, in that scenario, you don't necessarily need anything from us. So, if the customer can set the transmission up correctly for his application, then they have a lockup converter control, which is is yeah. Yeah, when the 4L60E came out, which is only an electronic version of the 700R4. In fact, GM changed the nomenclature of the 700R4 towards the end of its life and actually called it a 4L60. Then they came out with the 4L60E, which was a fully electronic version of the 4L60. Yeah, now you can use a 4L60E, and there are several versions of the 4L65 and a 4L70. You can use those in place of where you used to use 700R4s. The difference is, like a 4L70, a properly configured 4L70 is an extremely capable transmission. And so you really have a wide range of applications you can use that on. That comes in a factory application of over 400 horsepower. So it really gives you some capability there right out of the box. So it's you can really cover a lot of applications that way. Yeah, because what you won't have to worry about so much is how is this 700R4 configured? Right. Now some of the guys, some people you can't talk into electronics, and we understand that. That's not what we're trying to do here. What we're trying to do is, if your customer wants electronic trans, 4L60Es are extremely cheap to get a hold of, particularly if you don't care if it's new. You're looking at a reman price of less than $1,000. 700R4s are getting up there in price. They're harder to find, and what you don't have to worry about is you can go get a 4L60, and generally you don't have to worry about whether it's capable for your application. The 200R4, the 200R4, or 204R. Mm-hmm. Yeah, that's a shorter. Yeah, that's a better packaged gear train, so it's a smaller trans. So actually, the 200R4 gear train wise is identical to a 4L80. If you've ever looked at them, it's the same gear train design as a 4L80, just smaller. So really, it's a smaller version of the 4L80. Only they never made an electronic version of it. So it's basically a 3-speed with an overdrive unit added on the front of it. Whereas the 4L60 is a completely different type of gear train configuration. So they're not, the 4L60 and the 4L80 are not comparable in any way other than they're both made by GM. They're absolutely completely opposite each other in design. So continuing on, these are some of the other what we consider first generation 4-speed. So we consider these easy to calibrate, and we would sell these to any skill level person. Okay. The only exception there is the Chrysler. The first generation, there aren't a lot of Chrysler options because Chrysler kind of stepped over that first generation style control and went straight into some relatively complicated controls. The one exception is the 47RE, but the 47RE is only partially electronic. On the 47RE, you can't actually tell it what gear to go into. All you can do is move the shift points up and down on it. So it has an electronic governor, is what it has. It doesn't have a gear command system like the other transmissions. And then one thing to note is on the 4R100s, if you ever get into an application where you need a big Ford rear-wheel drive trans, we recommend sticking with the 4R100 over the E4OD simply because the E4OD does not have an output shaft speed sensor on it, which is a requirement for all of your modules. And so you would actually either have to refit that, or you would have to make sure you get the differential that goes with it that has the speed sensor on it, which if you're doing swaps and things like that, it's a real pain in the butt. Right. For most people, it's not a big deal. And the only thing it limits you is that because it's not a factory sensor, it puts you into, you have to use one of our higher level modules. Our simple off-the-shelf, our simple entry-level modules are 100% configured for what the 4R100 is. If you did that, yeah, if you put a 40100 sensor in it, then it would drop you back into, hey, I can use the 40100 control module, and it makes your installation a little easier. The same as all the others. So you have full converter lockup control, all your shift points, shift firmness, everything is adjustable on them. Yeah. The 40100 is equivalent to a 4L80, both in the design of the gear train and the electronic controls. The only difference is actually the E4OD 40100 family has one additional solenoid that is very useful, and that's the engine braking solenoid. So if you're electronically selecting a lower gear than what the selector is in, you still get engine braking with the E4OD 40100s, whereas the 4L80s, 4L60s, those you don't. Yeah. Yeah, so there's no real limitations to it. Just simply that output shaft sensor really is, for us, it's a tech support problem, because people will buy it and then there's no output shaft speed sensor and they have to figure out how to do it. So a lot of our customers, some of those things are difficult for them to do. Yeah, it's simply output shaft, and tail shaft housing. There are also some first generation 5-speeds. Okay, these are the GM 5L40, 5L50 family and the Ford 5R55E family, which is not to be confused with the 5R55 SW and N family, which fall under our second generation category. The 5R55E was really a small number of years that they used it. It was, I think, an A4LD was the original number of it, and they reconfigured the valve body and made a 5-speed out of it. So second generation transmissions. This is where it gets a little more complicated, and it also gets a little more difficult from the customer standpoint. These are any of the transmissions you're going to find from mid-2000s to present day. All of your clutch and band timing, everything is controlled electronically. What that means is when it shifts from one gear to the next, on some of the shifts, you have to release one element, reapply another element. In the first generation transmissions, that would have been controlled hydraulically, and all you would have just said was, hey, go to the next gear, the hydraulics take care of it, and it goes to the next gear. Now, in the second generation style transmissions, you have to control that timing electronically. So when you say, I want to go to second gear, you've got to time the release of one element and time the apply of another. If you miss the timing, you get tie-ups or you get flares. Flares are basically where the engine revs up in between the shift. A tie-up is where the vehicle feels like it noses over in between a shift. These transmissions fall under both internal and external controls, which means that some of them have actually the computer built into the valve body. Some of them have them external. And if you ever look at the hydraulics on these, the hydraulics are relatively simple. So because everything is done electronically, they just simply have solenoids that control your individual elements, and they don't worry about sequencing valves and things like that. So the hydraulics are relatively simple that way. There are some second generation 5-speeds, just like there's some first generation 5-speeds. What there aren't really are many second generation 4-speeds. Chrysler is the only one that has a trans that falls under that category. But there are some second generation 5-speeds. These are, they use external controls. There are no second generation 5-speeds that have internal controls or internal computers. Once again, there's more parameters to calibrate. They're also much easier to damage. Because as the tuner, you're required to make sure that the sequencing is correct. If you tie the trans up, that really does some damage to the clutches relatively quickly, and which means that the trans can be fragile for a beginner tuner. Now, once you figure out what's going on and you understand what's going on in the valve body, typically it's a very steep learning curve. So once you get a handle of what's going on, you can quickly make the adjustments and make the trans shift correctly. For these transmissions, we recommend that the customer has a hydraulic understanding of what's going on inside the trans, because it will help you in the tuning quite drastically. So if you understand what the solenoids are actually doing, then it makes your tuning much simpler. These are the second generation 5-speeds. Now, a lot of these, you'll see, this is where your typical Chrysler transmissions come in, both the 545 RFE and the NAG1, which is technically a Mercedes transmission, but Chrysler's been using it. You also got your Allison transmissions there. Those are, now there's also a 6-speed Allison, so you'll see it in both 5 and 6-speed categories. On these, yeah, so starting in 2000 and, I think 2001, 2003 maybe. Yeah, somewhere in there up to 2005 were 5 speeds. 2006 and up, they made it a 6-speed. And it's one of those, they're the same trans. All they did was did a valve body change to bring on another clutch, and they made it a 6-speed. Why they didn't make it a 6-speed in the beginning, I have no idea. So it's the same reason why didn't GM make the 480 a 5 or 6-speed in the beginning? It can be done. Yeah. Right. Now, for these style transmissions, we recommend you go through our dealer network. And the reason being is that we have dealers that their specialty are these individual transmissions. And so they can give you base cals, they can give you tuning support, and they can give you everything that you need to do these transmissions. The 5R110, on this list here, the 5R110 is our most popular one. There's a lot of Cummins swaps in Ford vehicles that they keep that trans. It's a good trans. There's nothing wrong with the trans. So when the engine goes out, they opt to keep the trans, swap the engine, and makes it the swap a little easier to keep in the factory trans. Our second generation 6-speeds. You'll find these both in internal and external controls. Some of them have mechatronic units. Some of them are external modules. The 6R80 is a particularly tricky one because Ford actually has it in both versions. There are 2 years of the 6R80 where the computer is built into the valve body, and then all of your recent years up to current, they're all external control. All that means for you as a user is it determines what type of interface you get from us. So if you have an external control transmission, then you would need our module that controls all the solenoids and gives you full control of the trans. If you've got one that has an internal controller, then you would need our module that works with the electronics that are already there. So we do them both ways. You have to know which one you have. Once again, these external controls are significant, not to be underestimated. It's a significant amount of calibration work. If you're an end user of these, you would expect to spend probably several months getting it exactly where you want. And that's because you're going to drive it a couple hours here and there. You're not going to work on it every day. Now, if you're a shop, you're doing this for a customer, I would expect to spend no more than 5 or 6 days. And it's simply because all these things are very temperature sensitive, and you usually only get one shot at making a cold adjustment before it's heated up and come through that point. So you're going to get one shot in the morning to make an adjustment, and if you miss it, you got to wait till the next morning to get it again, or you got to cool the trans down. So if you're a typical installer shop, you don't have a cold chamber to put the vehicle in, you'll have to do these, so you're not going to spend 5 days solid on it, but you're going to spend probably an hour or 2 a day on it for 5 or 6 days to get it exactly right. And also, on these 6-speeds, almost all of them are clutch-to-clutch transmissions, which clutch-to-clutch refers to a style of transmission where the handoff for the gear change, you're releasing one clutch and you're applying another clutch. So there's a point there where load is carried through 2 different gear sets. So one gear set that's coming off and one gear set that's coming on, both are carrying load. And so there's a specific tuning technique used to calibrate those style transmissions. Yes. And that's because the reason, yeah, there is. In fact, they want to get completely away from bands, and they want to get away from brakes. So a brake is a clutch version of a band. So it just stops something from turning, right? Well, the problem is when that element is turning and that brake or band is not applied, there's fluid friction between the 2 elements. So you're still getting friction. So in today's terms, where fuel economy, when it's released, right, when it's released, there's still frictional, there's still oil friction between the two parts. And so in today's world where fuel economy numbers are getting harder and harder to increase, they are taking extreme steps of reducing things like clutch drag. And so today's transmissions, in terms of efficiency, are quite drastic compared to your older 4-speed transmissions. I mean, there's in excess of 10% efficiency gain in a new transmission over an old transmission, just in clutch and spin losses. For example, like a 4L80. So if you know 4L80, you get from what 89 all the way to, well, I think they carried it into the 2000s. Okay, that trans versus a 6L80, which started in 2005, somewhere around there. The fuel economy difference between those two transmissions is drastic. Right, simply because they took extreme steps to reduce the parasitic losses, also to reduce the amount of items that are spinning at any one time. So by reducing the amount of things that are spinning, they're reducing spin losses, which is inertia, which takes power to accelerate that stuff up to speed, and then also the clutch drag. And so now the clutch drag thing came about after your 6-speeds came about. So what you'll see are there are several generations of 6-speeds, and the later ones are more efficient than the early ones. Simply all they did was go in and reconfigure the clutches so that at any one point in time, they might only have one clutch that is open. The rest of the clutches are applied. And that way only that one clutch is providing frictional drag. All the other clutches are applied. So they reconfigured it. So instead of having 2 clutches on at one time, right. And that's what a brake is. A brake is a clutch version of a band. So a band, all it does is stop something from spinning, right? Well, they do the same thing with clutches, where they'll put a clutch where it's splined to the case, okay, and it's got something spinning, and when it clutch applies, it stops whatever it is from spinning. That's technically called a brake, not a clutch. Yeah. So they'll call those brakes. Yeah. So they've. Yeah. Yeah. And so they've eliminated those. There are no bands and brakes in any of your new transmissions. That's because those are the worst ones in terms of drag. Yeah. So. So one last thing on the 6-speeds is that we provide a base calibration for all of these transmissions. So what that means is that if you're working with a trans that we have never done before, then you'll have to work with us to get a base calibration set up. And what that means is we'll configure the module for whatever trans that you're working with, and we'll basically lay the shifting methods out for you so that all you have to do is tune it. You don't have to actually worry about the multi-levels of configuration that's required. On your GM side, the 6L80, 6L90 is a second generation 6-speed. It has the control unit built into it, which means that you have no direct control of the solenoids themselves. They're all controlled by this little brick you see right there. Now these transmissions with our new, with one of our new modules, they're relatively easy to work with now. So we've taken the complexity out of it, and we've made them much easier to work with, as long as you stay within the original, well within the original design limits. Meaning that if you're trying to put one of these behind a 600 horsepower carbureted engine, you're going to have trouble. But if you put it behind a 400 horsepower fuel injected engine, that's what it came with from the factory. It's going to be relatively easy to make that trans work there. Okay, so on the 6L80, 6L90, as long as you stay within those stock power levels, you don't require any reprogramming of the mechatronic unit. So we're able to work with what's there. Our module will create the torque model along with whatever parameters are needed to make that trans operate correctly, and send that information to the transmission. So what we're doing is basically a piggyback system where instead of us directly controlling the trans, we're manipulating the module that's already there to get the control that we want out of it. Torque management typically is not required on these transmissions until you get above the 300 horsepower range. The reality is you can actually go well above that without torque management. It's all about how long you want the trans to live. The trans absolutely will shift great at 500 horsepower with no torque management for some limited amount of time.